Hello everyone, hope you're doing well. Welcome back to my channel. Today we are at day 11 of the January Daily Leetcode Challenge, and we again have a medium question in front of us. And from today we are going to enter maybe the topic of bit manipulation. This is one such question where there is a approach available, but you can also solve it using the bit manipulation. We'll see all the approaches possible. I will show you total 3 to 4 approaches for both Python and Java. So let us quickly begin what this question is. And remember, it has dealing with the topic of palindrome, and I've already given multiple examples of palindrome to you. But even if you are not sure of what a palindrome is, still I will show you multiple examples in this video also. Okay, so let us begin with today's question. It is 1400. Construct k palindrome strings. Okay, let me zoom in. Let us begin. Given a string s and integer k, return true if you can use all the characters in s to construct k palindrome strings, or false otherwise. Okay, what you have to do, we have to use all the characters available in s to form exactly k palindrome strings. If we are able to do that, we have to return true, otherwise we'll have to return false. Okay, I hope the question is very crystal clear to all of you. What we have to do, we have to use all the characters available in the string, and we will have to construct k palindromic strings. Okay, so what will be the length of the palindromic string? That is not given to us. It can be anything. It can be like changing also. Like there are multiple possibilities, as you will see in example one. For now, we are only given that we'll have to construct two palindromic stems in the example one of this given characters. Okay, that is the only constraint given to us. How many like what are the ways to do it, like how many times we can that is not something that we need. We only need to return true or false. Okay, if we can construct two palindromic strings using the characters here, then we have to return true, otherwise we have to return false. Okay, that is the simple question is that. Okay, something important here is all the letters are going to be lowercase. We will make use of this fact in the bit manipulation solution a lot. A lot will be this whole thing, whatever highlighted here, will be very important in deciding whether a bit manipulation will work here or not. We will see that when that solution comes. But for now, what we'll focus here is see this part. The total number of characters that we are going to receive is going to be in the range of 10 power 5, which is a lot. Okay, which is a lot. But one great thing that we can make use of is that there are going to be only 26 characters that are unique. Only 26 unique characters are going to be there. Okay, so that is something that you can make use of. And k is also going to be in the range of 10 power 5. Okay, yeah, let us quickly see what we are going to do. Okay, so before that, I will show you some of the theories here. What is a palindrome basically? So palindrome, as you might be knowing, if you read a particular word from left to right, okay, and similarly a word from right to left, if both the words, when you read them in the sequence, if they are same, then we can say that is a palindrome. For example, let me show this. See this part. If you start from left to right, you will get a double b a. Similarly, if you start from right towards left, you will again get a double b a. That is the sequence in which characters are appearing in both the cases. Okay, left to right and right to left, they are same. That's why we call them as palindrome. Okay, point number one. Now there are two types of palindrome which are see, because this question is totally revolving around the topic of palindromes, you should know everything that you can know about palindrome. Okay, so what is the first case? See here, even frequency character. That is, see, idea here is, since the sequence matters, the way in which the character appears will matter. Okay, the sequence in which the character appears will matter. So see here, if the first case is even frequency characters. Okay, see here, the length of this particular word is going to be even in this case. Okay, the idea here is every character is appearing for an even number of times. Okay, why it is so? The idea here is whatever is here, the first character, that has to be the last character also. Similarly, whatever is the second character, that has to be the second last character also. For that reason, it is going to have even length, and all the elements here, that is all the unique characters here, are going to have a frequency which is even. Okay, either 2, 4, 6, 8, something like that, but all of them are going to have even frequency. Okay, so this is the case of even frequency characters. Okay, fine. What is the other case? This case is going to be very important in the current question. Okay, so see this case first. One odd frequency character. So what will happen here is, the only difference between this and this is that here the length was even, but here the length is going to be odd. So since the length is going to be odd, what will happen here is, here the first character has to be the last character also. That is fine. Similarly, the second character has to be the second last character also. That is also fine. But as you will see, the third character and the third last character, they both are same. That is, they are not different. That is, this character is present only once. That's why we call this kind of things as one odd frequency character. So if you see what is happening here, if we have more than one odd frequency character, then it will be a challenge for us to create a palindromic string. The idea here is each odd frequency character should be part of a palindrome, that it should be in the center. Okay, as simple as that, it should be in the center. If it is not in the center, we cannot form a palindrome out of it. So this is something that I want to pay attention to, because the whole question is revolving around this topic. See here, if there is odd frequency character, that is a character which is having frequency 1 or 3 or 5 or 9 or whatever it is, if it is odd, then what will happen is the case will come where it has to be present in the middle of the string. Okay, we can do the palindrome. Only case is that the odd, only one odd frequency character should be there. Okay, as simple as that. So out of that one odd frequency character, one palindrome will formed. Okay. Now the challenge comes when there are more than one odd frequency characters. Okay. So that's why the k here will also matter. Okay. Now the the term k will now come into the calculations. So I've taken example here. See this part. If the word given to us, let's say S is like this. Okay. Double A B C. Okay. Here A has even frequency and B and C has odd frequency. Okay. So odd frequency is B and C. Now I'm just recording the characters which are having odd frequencies. So in this case, odd frequency character equal to 2 because B and C are having odd frequencies. Okay. Now see here. Now when k equal to 4. So in this case, it is very, very simple. Like each character in itself will form a palindrome. That is, the palindrome will be of length 1. Okay. So this A in itself is a palindrome. This A in itself is a palindrome. And similarly, B and C. Okay. Here, the length of the word and the k are same. Okay. K equal to 4 and n also equal to 4. Okay. And one more thing that you can see here is the odd frequency character, which is 2, E here is less than equal to 4. Because of that reason, the answer is 2. Okay. What is this? Will come to this. That is, this is how I'm going to formulate the answer. But see the other cases. Now we'll go one by one step lower. Okay. Now let us talk about k equal to 3. Okay. What is happening here? See, what we can do is we can combine these two A's and form a palindrome. Okay, like this. And similarly, the two remaining characters which are unique can be a palindrome in itself. Okay. So for k equal to 3 also we are done. So in this case also, since the odd, okay, the odd frequency characters are 2 and it is less than equal to 3, still we can form a, satisfy the constraints. Okay. Now coming to the case when k equal to 2. Okay. Now pay attention here. What we have to do is, see, this is a we have to form two palindromes. Okay. The idea here is, since it is a odd frequency character, it has to be there in the middle. Okay. So I kept B in the middle and surrounded by A's. Okay. And C, I left it as it is. Okay. As simple as that, because I don't have any other even frequency character. So C will be like alone itself. Okay. So here also we see 2 is less than 2. Okay. What is the first two? 2 is the odd frequency characters, and what is the second two? Second two is the k. Okay. Second two is the k. Still 2 is less than equal to 2, so it is 2. Now see the case here. When k equal to 1, you cannot do anything here. The idea here is, see, if you try to form a single palindrome string, idea here is, if there had been one odd frequency character, we could have done it. But here B and C both are odd frequency characters. Now which one should be in the middle? Any one of them only we can keep in the middle. The other one has to be having a even frequency. Otherwise we cannot do, right? So for that reason, for k, when k equal to 1, it is not possible. And if you see the reason, the idea here is 2, which is the number of odd frequency characters here. Okay. It is, when we try to see if it is less than or equal to 1, it is not the case. That is false. That's why we are calling it as false. So now I am sure that we would have understood the logic. The idea here is, count the, characters which are having odd frequency. If that count is less than or equal to the k, then we can conclude that yes, it is possible to form a, such a palindrome strings. If it is not less than equal to k, like we saw in this case, then it is not possible to form palindromic strings. Okay, as simple as that. Okay. So we will do the same thing here. See here what I'm going to do. So I'm first showing the Python solution, then we'll see both Java solutions, and then we'll come to the bit manipulation topic. Okay. So see this part. First case is, if the length of S itself is less than k, it is not at all possible to even think of, forming k palindromic strings. Okay. For that reason, simply return false as it is. Okay. Now I am creating a frequency map. What is a frequency map? For each character, it is going to store the frequency. That is how many times it is appearing. Okay. So this I'm using the default dictionary data structure. Okay. It is similar to, the mapping, the, key value pair data structure. But here I'm, using a default dictionary because it will be giving me the default values. Okay. As simple as that. Now I'm going through every character in S, and I am, updating its frequency by 1. Whenever a character appears, I will update its frequency by 1. Okay. I will increment its frequency by 1. Okay. Then I'm creating another variable called odd frequency character. Okay. And then what I'm doing is I'm going through all the frequencies. Okay. The frequency, the numbers. And if a particular frequency is odd, okay, that is I percentage 2 is equal to 1, that means it is odd, then I am going to increment this particular variable. Okay. So this variable will tell me at last how many characters are having odd frequency at last. Okay. Fine. Now, if the number of variables having odd frequency, if it is less than equal to k, then we are good. We can return true that it is possible for us to form k palindromic strings. Okay, as simple as that. As I showed you in the case here. Similarly, you can, prove that it is always possible whenever the number of odd frequency characters is less than equal to k. Okay, but if the odd number of odd frequency characters is not less than equal to k, in that case it is not possible. Okay, in that case we'll have to return false. Okay, let me quickly run the selection and show to you. So as you can see, this is clearing all the test cases. You can segment this solution. It is very much optimal. At the same time, this, clears all the test cases possible when you segment it. Okay. Now, if you talk about the space and time complexity for this, see this part. I'm going through each character in S. So definitely it is a O of n solution where n is the number of, that is n is the length of the string S. Okay, as simple as that. Now, since we're using this particular data structure, okay, so can you quickly tell me what is going to be the length here? That's how many keys and values we are going to store at max. As I mentioned here in the starting of the question itself, since S is only going to consist of lower English case letters, okay, so there are only 26 possibilities. So at max, this data structure is only going to store 26 key value pairs. Okay, at max, I'm saying. Remember that it will not be the case every time. Okay, only 26 at max it will going to store keys. For that reason, the space complexity is going to O of 26, which is equal to, okay, we can also call it O of constant or O of 1. Okay, whichever way you want to write it, you can write it. It's going to O of 1. Okay, now coming to your time complexity, as I mentioned, we are going through each character, that is we are traversing throughout the length of the string S. For that reason, it's going to O of n. Okay, as simple as that. So yeah, friends, this was the Python solution. And now coming to the same code for in Java, the same thing we are now going to do in Java. See here, I'm capturing the length S. Okay, I'm going to capture the length for the string S. Then we are checking if n is less than equal to k, return false. I'm going to create a map, okay, which is going to point to a hash map. Okay, here I've given 26 because at max this is going to store 26 characters. That's why I'm, starting itself I'm providing the 26 here, so that in order to ensure that, okay, it doesn't have to, during the runtime it doesn't have to seek for a new memory space to keep those characters. So it already has enough space to store 26 key value pairs. Okay, for that reason I'm passing 26 here. Next, I'm going through each of the characters here. Okay, what I'm doing, I'm converting us to a char array, and then I'm iterating over it using the character C. Okay, then we are just checking whether this particular character is already there. Okay, is this particular key is already there in the frequency map? If it is already there, what I have to do, get its previous value and add one to it, and again put it inside the map. Okay, that is, whenever we are seeing the character, we are incrementing its frequency by 1. Okay, if it is the first time we are seeing that character, what we have to do, we have to insert a key value pair where C is the key and the value is 1. Okay, because it is the first time that we are seeing it, so its value is going to be 1. Okay, see this part how long it is looking, but see this in Python when I'm using the default dictionary, how short it is looking. Okay, that is the beauty about Python. Okay, now coming to the other part, here I'm declaring a particular variable which will store the number of odd frequency characters, that is the number of characters, unique characters which have a odd frequency. Okay, as simple as that. Now what I'm doing, I'm going through all the values in the map. Okay, remember, only the values, not the keys. I'm going through all the values in the map. Since the values are integers, so I'm iterating them using a integer variable. Okay, if the frequency is the odd one, that is percentage 2 is equal to 1, in that case increment this particular pointer by 1. Okay, at last, once I come out of this particular for loop, see here, if this particular, that is the number of odd characters sorry, number of characters having odd frequency is less than equal to k, return true, otherwise return false. Okay, now just a small observation is that, see this part, how clumsy it is looking. I just want to show you how to do it in a neat way. Okay, so just the next solution that I'm showing you, exact same solution, but this particular part I'm going to do in a neat way. So see here, yep, this is where we are doing. See here, this part. So what you can do is, I am going to reinsert the value for character C, whether it's there already or it's not there already. I'm going to reinsert it. What we are going to reinsert, see this part. I'm using this particular function, get or default. That is, if this key exists, get its value. If this key doesn't exist, get the value 0. Okay. The idea here is, if the key exists, okay, get the original value and then add it by 1. If this key doesn't exist, return the value 0 and then add 1 to the 0. So it will become 1. So as you can see, this whole part, how clumsy it is looking, you can make it much readable by writing this code. Okay, this part of the code. I'm just using this particular function, get or default. Okay, this is an inbuilt function for the map. Okay, hash map class. As simple as that. You can just use this. So yeah, the rest of the solution is same. And yep, now coming to the bit manipulation solution. Now see the idea, how to get this idea. The idea here is, if you see, we do not need the actual frequency. We just need to know whether it's a odd frequency or even frequency. Okay, we need not know the actual number. For example, if frequency is 9 or a 900 or 999, whatever it is, we are not bothered about that number. We are only bothered whether it is going to be even or odd. Okay, for that reason, it doesn't make sense to store that number. Okay, the number can be big. If you see here, it can be up to range 10 power 5, right? So let us say the whole S is made of a single character, so the frequency for that will be 10 power 5. Okay, in the range of 10 power 5. So it's not a good idea to store them, because it will take a lot of space to store such a number. So the thing that we can use is, see this part, since all the letters are going to be in smaller case, so only 26 characters are there for us, okay, to decide. And for each of them, we just need to know whether it is a odd frequency or a even frequency. Okay, a true false, that is a boolean value. For that reason, we can think about a bit manipulation solution. Okay, so for example, in a integer, okay, it's going to be 4 bytes, which equals to 32 bits. Okay, we have 32 bits space. Even if you exclude the MSB or for that reason other bits, you still have enough characters, that is at least 26 characters are definitely present. Okay, so you have at least 31 characters present. that we can make use of. So the next solution what I'm showing is we are going to do that. Okay, so here we are going to use each bit. Okay, we are going to use each bit to mark whether a particular character is having the right frequency or not, or even frequency or not. Okay, so each bit will be representing each of the characters, okay, from A to Z. So we are going to use 26 bits, and we are just going to I can say like flicker them, that is alternate them whenever we see a character. Okay, that is, if for the first time we are seeing it, we will make it 1. The second time we are seeing it, we will make it 0. That is, we will be you know shifting that is, we'll be just switching between the bits. Okay, as simple as that. So see here what we are doing. Yep, first of all, the same thing, if length is less than k, return false. Okay, I'm just declaring this variable now again, or frequency characters. Okay, then I'm recording the ASCII value of a. Remember, this particular operator in Python will give you the ASCII value of that particular character. Okay, so this will give me the ASCII value of a. I am storing it here. Okay, now I'm going through all characters in S. What I'm doing is, see this part, I am finding the, okay, I am subtracting the ASCII value of the given character with the ASCII value of a. Okay, for example, the ASCII value of Z, I'm subtracting with ASCII value of a, so that will give me 26 or 25. Okay, it will give me that. Okay, so always the answer is going to be in the range of 0 to 25. Okay, as simple as that. Now I am going to shift 1 that many times. Okay, see this part, if I shift 1 by 2 times, I'm going to get the number 4. Okay, and the binary for that is this. Okay, that is, 1 was in the 0th place, and now it got shifted to this place. Okay, it got shifted to 2 places. That's why it's called a left shift by 2. Okay, so this particular one is left shifted by 2. So similarly, if you see, this particular one is left shifted by these many times. Okay, so 0 to 25 times it will be left shifted. Okay, depending on which character we are seeing currently, which character is I, based on that it will be shifted. Okay, and now this shift I am going to XOR with this. Okay, so it is, the idea here is, see here. So for example, take this case, let us say already, let me like take a situation like this. Let us say this particular character, okay, it is going to represent C. Okay, this represents C because the first character is A, second character is B, and the third character is C. Okay, it is representing C currently. Now let us say we are again going to get a C. So what we are going to do, I am going to do XOR again with this. Okay, I am going to do XOR with this. Okay, I'm going to do XOR with this. Okay, so this will be the XOR, right? So what will happen, see here, so now which are already 0, okay, these will be, either this can be 1 or 0, right? So the idea here is, if you do XOR of any number with 0, what will happen if it is 0 already? If this number is 0 already, what will happen? 0 XOR 0 will remain 0 only. Similarly, if this number is 1, okay, 1 XOR with 0, it will remain 1 only. Okay, so the idea here is these particular bits will not be affected. The only bit which will be affected is this. Okay, so this bit, if it is 1 and you're doing XOR with 1, it will become 0. Okay, the resultant bit will become 0. See here, it will look like this, 0 0 0 0. Okay, so the result is going to look like that is, even this particular bit becomes 0, and let us say this bit was 0, so 0 XOR with 1, it will become 1. So the idea here is it will be alternating after that. Okay, if it is 1, it will become 0, if it is 0, it will become 1. So that is the basic idea that we are going to follow. Okay, as simple as that. Okay, right. So that is what we are going to do. So if you see here, that's what we are doing. I'm going to take the original part, and then I'm going to XOR it with this particular part. Okay, here we are left shifting 1 by these many times. Okay, as simple as that, right? Once that is done, what I'm going to do, I'm going to convert this particular number. Okay, that is the integer in which we are marking the frequencies. Okay, I'm going to take the binary of it. How it is going to look, see here, if you take binary of 4, it is going to look like this. Okay, 0b will be maintained initially as a prefix, and then you are going to have the actual binary representation. So in this, I'm going to count how many ones are there. Okay, so whichever are the ones, okay, that is going to tell me how many odd bits are there. Okay, see this part, initially everything will be 0 0 0, and then when we see a number for the first time, it will be made as 1. Okay, then again, let us say we are having it for the second time, so it will be made 0, and again let us have say we are having a third time, it will be made 1. So idea here is, whichever frequency are odd, that place 1 will be present. Okay, that's why we are counting 1 here. Okay, we are just checking for 1. So if the number of ones is less than equal to k, we are good, otherwise we are not good, we have to return false. Okay, so this is the condition that we are returning. So the result of this will be true or false. Okay, so let me quickly run this and show it to you. So as you can see, this is also clearing all the test cases. We can segment this also. Okay, this was see, in the previous session as I showed you, here it was O of 26. Okay, though it is also constant, still it was O of 26. But here in this currently, if you see, we are just using a constant variable. Okay, it is just a variable which is having just as an integer space, and we are using it. Okay, we need not store for each of the characters A to Z, we need not have a particular place to store it. Okay, or array or something like that, or index like that. Okay, within a single integer, we are using the bits to store the data for that. Okay, so this is a very much optimal solution in terms of space. You can check that out, but in the time complexity still remains the same. We have to go through each of the characters here again. So it is again O of n, but in terms of time complexity, and O of 1 in terms of space complexity. So yeah, fun, that was all for this particular video. I expect you to take this code and run it by yourself. try to understand what is happening. See, this part, it may look, a bit confusing to you initially, but when you see it, see, you have to understand this part. As I mentioned, no, see what will happen. See, the idea here is, you're only talking about this part, but what will happen to the rest? Let us say this particular part here also, zero will be there, here also one will be there. So what will the effect of this when we are, doing the left and we are doing the XOR? So try to understand those parts, because this part, so these things will come to you only by experience. Okay, please do take this kind of code and try to understand it in depth. Okay, simply do not submit and leave it. Okay, only if you are understanding in this particular code, you will be able to use it in an interview where you will not be getting any such help. Okay, you will be just be getting some ideas that, okay, can we sort in a bit. So you will have to code the whole solution out. Okay, so whether, just check yourself whether are you able to think of such a solution or not. Okay, if I give you the hint that try to use the bits and store this particular information, whether you are able to come to this idea or not. Okay, so this is all about, brute force kind of idea. Okay, you'll have to keep trying, and then you will hit a solution that, okay, if I do XOR, it will still work. Okay, so these things will come by practice. So please keep trying. Okay, that is the only thing that I can tell you. You need not reach this kind of solution in one go, but if you are given a hint, you should be able to reach this kind of solution. Okay, in the interview, I'm saying. So yeah, friend, that was all for this particular video. I showed you both Python and Java solutions, and for the bit minimization, I showed you the Python solution. So yeah, friend, that was all for this particular video. If you like my efforts, please do subscribe to the channel. This really gives us a lot of motivation to continue further and to bring more such questions to, okay. And especially like from the last few weeks, we saw a few questions on try. So if you have not seen them, please go and try that out, especially the day 9 and the day 10 questions. They were totally on those topics. Please go and check them out if you have not done so. So yeah, friend, that was all for today. Please subscribe and see you tomorrow. Thanks a lot.